What we do today in one variation, shape, or form, we will be doing every day through Friday, okay? So, we'll start today and then we'll keep on going. And one reason you don't have a quiz today is because the quiz is going to be based on this kind of stuff. So, we'll teach it today and then we'll reteach through the quiz over the next couple of days. Use factoring to solve the equation. I don't know why they ask you to use factoring. You don't even know how to factor yet, but you don't really need factoring to this. Did anybody double distribute both sides? And then did you notice the x squareds went die-die? Right? There's an easier way to do it. I'm going to divide by x minus 2. Die-die, die-die. Okay? By killing those, I'm just dividing both sides by the same exact thing. Okay? So, dividing by x minus 2 eliminates that term, and then I'm down to 2x minus 3 is equal to x plus 1 minus the x. God bless. X minus 3 is 1. Add 3. X is 4. Now, did anybody get x equals 4?
No.
I think there should be people, but it was a lot more work than that, wasn't it?
Oh, yeah.
Yeah.
I did it, and I double distribute this x squares didn't cancel out.
On both sides, you should get, you're gonna get a 2x squared on one side and you're gonna get an x squared on the other, so you're gonna subtract x squared, yeah. What happens is, if you double distribute, you will lead yourself into what we call a quadratic equation. And when we get back from the break, we're gonna learn all about those. One of the points behind the Common Core, and we talked about this yesterday, was the ability to see a little bit deeper into this. And what you have here is the fact that since both sides are being multiplied by x minus 2, one of the ways to approach this is to divide both sides by x minus 2. Now, there's one other thing that we have to keep in mind about this, and it's the following. Another answer is 0. Can anybody think of why another answer is 0? Oh, I'm sorry, it makes 0. The other answer is 2. Can anybody think of why it's 2?
Because you can simplify it.
Well, if I took the 2 and plugged it in here, what's 2 minus 2?
0.
0. And I plug it in here, what's 2 minus 2?
0.
So 0 times this thing is
0.
0, and 0 times this thing is
0.
so then indeed both sides would end up being equal to each other, okay? So it's a food for thought situation. The best technique to solve this is to double distribute, is to get it all on one side. We haven't learned that yet. So how could you approach it if you haven't learned it yet? One way would be to say, well, both sides are being multiplied by an x minus 2, so I could divide those out. Then I could solve what remains. The only hitch in the ointment is if you do that, you have to ask yourself, well, would anything have worked for the x minus 2? And the answer is yes, 2 would have worked for that, because both sides would end up being 0. Okay? All right. So 4 and 2 would end up being the answers to that. All right. So now, rearranging formulas. Okay? If the width is 10 inches, what's the length? Should be pretty easy. 2.5, right? Because if it says here the width is 10 inches, so then 10 times 2.5 is 25. Agree?
Yeah.
Okay, if the width is 15 inches, what's the length? Well, it's going to be 25 over 15,
It's gonna be
which is 5 over 3. Okay, good.
What?
5 over 3.
You don't keep it a decimal?
No.
We don't like decimals.
Remember?
Well, how come?
What was your decimal?
1.615.
That would get full credit. A lot of people will put 1.7, and some people will put 1.666666667. So if you did put 1 2/3, you're fine, because they're equal. But if you put any shortcut for 1 2/3, you would be wrong. Okay,
Does it have to be in function?
I just said you would be full credit.
Oh.
Okay. All right. Now, another way to do this is to rearrange the area and solve for L, because we want to find the length. So I divide both sides by the width, and I get that the length is the area divided by the width. So for instance, back when we said the area was 25 and the width was 10, what's the length? 25 divided by 10 is 2.5.
Or
Okay.
5 over 2.
Or 5 over 2. Or 2 1/2.
Then 2.
Okay? Any of those combinations. So the point being that a formula like this is really 3 formulas in one. It's area is length times width, or I could divide by the width and say the length is the area divided by the width, or I could divide by the length and say the width is the area divided by the length. All three of those are similar ways to look at this formula, okay? All right, verify the area formula, solve for L will give the same result as L. All right, we just did that. We came up with 2.5. All right, so, again, all of those questions are all Common Core. I don't think those questions are hard. It's just that the Common Core tends to look at them a little bit differently than, or tends to look at things a little bit deeper than we're used to doing. And in so doing, it wants to drive us to a deeper understanding. One of the big things the Common Core talks about all the time is less topics, deeper understanding. Less breadth, more depth. Okay, so now we look at this one here. It says circle all the ordered pairs that are solutions for 4x minus y equals 10. I only want to do the first row. I don't want to do the bottom row. It takes too long. So look at the first row and find all the solutions that work for 4x minus y equals 10. There may be more than one, I really don't know.
Oh.
Because it does say find all of the solutions. It doesn't just say find the solution.
Just the top row?
Just the top row.
Can we do the bottom row or?
Nah, I'm gonna go do it in about 10 seconds. And there is such a thing as overkill. All right, so I'm just gonna plug the points in and see if they work. If I plug in a 3 for x and a 2 for y, this one works.
Yes, it does.
Okay? So it says circle, so I will.
What did you do?
Unbelievable. This works. 2, 3, nah. -1, -14. That'd be -4 minus a -14. That works. 0, 0. I don't think so. 1, -6 would be 4 minus a -6. This works also. So the odd ones, the first, the middle, and the last, all work. Agree?
Yeah.
Okay. So what they want you to see is this. The point they're driving at is when you have two variables in one equation, there are a lot of solutions. See, if I give you this equation, if I just change this slightly and say 4x minus 2 equals 10, there's only one solution, namely 3. Okay? But as soon as I put two variables here, an x and a y, there are an infinite amount of solutions. In fact, we talked about how when we graph it, this graph would be something like this. Every one of these ordered pairs will check or satisfy in that equation. That's what the whole point behind the graph is. The graph is a picture of all of the points that satisfy or check in a given equation, and we connect all the dots, okay? Now, how did I decide? I simply plugged them in and checked. So now, if it's one equation with two variables, there's an infinite amount of solutions. Now, for the top one, there are an infinite amount of solutions. A's and B's that together will work. For instance, one answer would be if A was 0, B could be -8. Another answer is if A was 3, B could be 1. Infinite number of answers. Likewise, if I cover up here, there's an infinite number of answers for A plus B is 4. One is 2 and 2, one is 1 and 3, one is 0 and 4. What we're driving at here is what's the one solution that works for both? What's the one solution that satisfies both? If I was to graph these two, and we did some of these already the other day, the two lines would cross at a particular point, and the coordinates of that point would be what we call the simultaneous solution. That is a graphic solution. We graph one, we graph the other. The point where they meet is the simultaneous solution. Do you remember that? Okay. With inequalities, it's the same thing, but we shade one side and we shade the other. And we call it, like, if I shaded this side and if I shaded this side, then we say we write a great big S, and the solution set is where they are double shaded. You with me on this so far? Okay. Now, the question becomes, can I do it another way? Or do I have to graph it every single time? Thank you so much. Okay, it's all her fault. Every day it seems. Always gets me to go. Now, there is a way to do this. What I can do is I can combine the equations. Just like I can do graphs to both equations at the same time, I can do algebra to both equations at the same time. Now, the rules with algebra is really simple. As long as I add equal things to equal things, you get what? Equal things. Okay. So, for instance, this left side of the equation is equal to the right side. This side equals this side equals this side. So we're going to add up the lefts and add up the rights, and they have to be equal. So what's 3 A's plus an A? Sweet. What's minus B? Oh, this is cool. This is good. This is sweet. What's a negative B and a positive B if you add them up?
0.
0. Die. Equals. What's 8 plus 4?
12.
Now, do you see how beautiful that is? That's like a work of art. It's so beautiful because I got rid of one of the variables. Now, because I got rid of that variable and I only have one letter in a line, I can solve. What does A equal? 3. Divided by 4. Divided by 4. A is 3. Okay, great. But the letter, the problem has 2 variables in it. I haven't found both variables. What have I found so far? I've only found the first one. Anybody have an idea how I can figure out B? Alex?
4 minus A
4. Okay, yeah, we could do that.
from the second problem.
Yeah, what Alex did that's really slick, and I'm going to go over here and do it because most people wouldn't do it the way you did it, but it's really slick to do it that way. What Alex did was this. He said, oh, I'll get B by itself, so I'll minus the A. And I'll get B is 4 minus A. So if A is 3, B is going to be 4 minus 3, B is 1. That's a great way to do it. That's got like style points added in for that one. However, most people would be a little lazier than that, and they would have said, well, A is 3, so I'm just going to put the 3 in, all right? That's what most people would do. And then I'm going to minus the 3, and B is 1.
That's what I did.
So the answer is that A is 3 and B is 1. Now, you can check this guy over here. I always like to write the word check so the teacher knows what the heck I'm doing. Okay, A is 3, so 3 times 3 minus 1 equals 8. What's 3 times 3? 9 minus 1 is 8. So 8. So 8 is 8, check. And then the other one would be 3 plus 1 is 4. Yep, that's true. 4 is 4, check. Okay? So basically, what we do is this. We say to ourselves, this is called the elimination technique, and we're saying, look, as long as they're lined up like this, if I can get the same number to match here, the same number of B's or A's, doesn't matter which one, I can add them up and it eliminates that A. That's why we call it the elimination technique. So we can get rid of one of those terms, and that will always leave us with just one variable. And as soon as I have just one variable, now, Hunter, thank you so much for that. You want?
Why would you do that?
Now I can solve the variable. Okay, so let's have some fun.
Yay.
Give it a shot.
Okay.
Play. Okay, so, anybody feeling a little stuck? We have 2 people, 4 people, 5 people telling the truth, 7 people, 8. Oh, you mean I'm supposed to be stuck? Anybody find clear sailing? Where they're like rocking it, like, man, I got this. Okay.
Not really.
No? All right, well, when I show you how to do this, part of you will go like, ugh. But deep down inside, you're going to say, that's not so bad.
So it's gonna be like a really short little thing where you just put like
Yeah,
a line or
right.
something, and then it's like, oh, there's your answer.
Nah, it won't be that short and simple. But it'll be very doable. So, what's the problem? Why doesn't this one work? I mean, on the previous one, it was sweet. Look, I just added them up, and I got 4a is 12. What about this one?
Nothing cancels out.
That's right. There's the problem. The problem is, I think that Hunter and Francesca are conspiring. If you just add them up, nothing cancels out. You get 5x plus 3y is 7. Whoop-de-darn-do. You haven't done any good at all. So,
You need to subtract them.
no, that wouldn't work either because I'd get negative x plus 7y is equal to negative 9. No. What you're going to do is say to yourself, I need to get a common number of them. I need to get the same number, like it was a plus 1b and a minus 1b. So when I added them up, they wiped each other out. So I have to find a way to get to have the same exact number of x's or y's. And I will tell you that I would prefer to get rid of the y's because the signs are different. Life is easier when the signs are different. Okay? Now, I'm going to go back to an old trick from elementary school. It's not even a trick, it's just a technique. Trick is a bad word. What I'm going to do is I'm going to treat this like fractions. In the sense, I know, see, I said no, you go, ugh.
I totally forgot about
What I'm going to do is treat it almost like I treat common denominators. See, when we have an equation, isn't it true that I can multiply both sides by the same thing and I will not change the answer? Right, does that make sense? Okay, so what I'm going to do here is I'm going to say it would be really, really cool if they both had 10 y's, wouldn't it? Because one would be positive 10y and one would be negative 10y. Well, I can make them both have 10 y's.
No.
I can multiply the top one by 2. And that gives me 4x plus 10y equals negative 2. Which would be the same exact solutions because all I did was multiply both sides by 2. So if x is 5 and I multiply both sides by 2, 2x is 10. No problem. Now, what could I multiply the bottom one by that would give me negative 10y? Everybody? 5. So now I get 15x minus 10y equals 40. Now, can you see the die dice?
Yes.
Okay? So I add them all up. In fact, I'm going to pause now, and you guys can get cracking on it, now that you know how to match them up. Yes? No. The first one, look at them separately. Look at the first one as having a single answer. Let's say x is 20 or whatever, or x is this x? Yeah. X is 2 and y is 3, whatever. If I multiply both sides, then 2x is going to be 6, or 2y is 6, or whatever. As long as you multiply by the same thing, both sides, you keep the values the same. Think about it this way. No. Think about it this way. Think about it graphically. Let's say I had an equation that looked like this.
Do I have to solve for y?
Oh, yeah. Let's say I had an equation that looked like this. Y equals a half x plus 4. And let's say I graphed it. There's my equation. Agree? Right? Now let's multiply everything by 2. And I get 2y equals x plus 8. Well, this equation is the same as that one, because when I divide it back by 2 again, I get back the same equation, and I would graph exactly on top of it. So all I did was multiply this equation, which has its graph, by 2. So when I graphed it, I would get the same exact equation back. And likewise for the bottom. So if this was a picture of one of them, and it stays the same, and that's a picture of the other, the solution will not change. Okay? So you can multiply and divide any fraction, both sides of any equation, by the same thing, and you'll never change the answer. once you, with this elimination technique, the only thing about the problem that I think is fairly difficult is matching up the variables. In this case, knowing to multiply the top by 2 and the bottom by 5. That means my 10y's match up, and I get 19x is 38, and I divide by 19x, and I get that x is 2.
Yay.
Now, a lot of times, students will think that you're done with the problem, because all your life you've been doing these equations, and if you get to the point in the equation where you say x is 2, you're normally done, right? But what's the problem here?
You guys have to like
You got to solve for y also. So I can go back, now listen very carefully. See these red equations here?
Yes.
These are called derived equations. What do we call this? Derived equations. And it's called derived because it's not what you started with. It's what you figured out a little later down the line. To derive something means to deduce it. Now, I never, to find y, want to use one of the derived equations. I always want to use an original equation. So make sure you go back and you use any of the equations in black. I don't want the y to be negative, so I'm going to work on the positive, on the equation where the y is positive.
Oh.
2x plus 5y is negative 1. It makes no difference. It's just that you're more likely to make a mistake if it's going to be negative. So x is 2, so 2 times 2 plus 5y is negative 1. 4 plus 5y is negative 1 minus the 4. And I get 5y is negative 5. Divide by 5. Y is negative 1.
You still got negative.
So, yeah, it's not that you won't get a negative answer, it's that I won't have to multiply or divide by a negative to get my answer.
Well, is negative better than 2?
It's not that the other way is bad, I just think that to have it positive, you're a slight little bit less likely to make a careless mistake. Okay? So again, let's go back to the theory behind this. There are an infinite amount of answers to the first equation, because there's two variables in a single linear equation. Infinite amount of answers. If I graphed it, it would look like this. Then there are an infinite amount of answers to the second one. If I was to graph that guy, probably look like that. But there's only one answer that's common to both, namely the point of intersection. Now I can figure that out by graphing both of them, or I can figure it out algebraically. There are two algebraic techniques, one of which is called elimination. And today we played with elimination for the first time. We're going to play with it again each of the next few days. It's a very common Regents type of question, so it's one that you have to learn to be comfortable with. Okay? Sam, you have a question? Okay, are we good? All right, so now what I would do if I were you is I would turn to your homework question that looks like an elimination problem. And I would work on that one first, perhaps talk to the people sitting around you, and then once you're done with that one or two, I would work my way toward the rest of the questions, which are far more typical. Okay?
Mr. Lucas,
Yes.
how would you put that into a real life problem?
Oh, it's funny you should ask. That's exactly the quiz I'm about to make up, is to turn this into